Well, guys, another day, another format of recording this. Loom nor Vidyard, they both don't work, so I'm going to try something new today. Let's start a daily challenge. Sweet. Okay. Question number 2246. Longest path with different adjacent characters. Okay, so another tree question. We've been getting tree questions for pretty much for the past like three questions. They've all been these. Let's start. You're given a tree, a connected undirected graph with no cycles. Rooted at node 0, consisting of n nodes numbered from 0 to n minus 1. The tree is represented by a zero-indexed array parent of size n, where parent I is the parent of the node I. Since node 0 is the root, parent of 0 is -1, so a non-existing parent. Okay, pretty straightforward. Another instance where the tree isn't given to us as nodes with variables left and right or children. Here, the tree is given to us again as just an array of relationships. Previously, they were edges. Now it's an array of parents where the index is the node and the value is the parent. You're also given a string s of length n, where si is the character assigned to node I. Okay, makes sense. Return the length of the longest path in the tree such that no pair of adjacent nodes on the path have the same character assigned to them. So this sounds like a longest path or like the longest depth question. Seems like we can just start at A, at the 0th node, and then do DFS to figure out what the and keep a track of the longest path, I guess, starting from 0. Let's look at the example. Input parent 0th index is not existent. The first is 0. The second is also 0. The third is 1. The fourth is also 1. And the fifth is 2. Okay, makes sense. String S, A, B, A, C, B, E. A, B, A, C, B, E. All good. Output 3. And I'm guessing that the output is going to be A, B, C. Because it can't be A, A, E, as these nodes are the same. And it can't be A, B, B, because these would be the same. So A, B, C seems like the correct answer. What's this? A, C, A. So how would I know? Alright, so first of all, this is not a binary tree. This tree has many children. A node can have many children. And why is it 3? Why is it not 2? Parents, that all makes sense. The 0th parent is -1. All of these parents are 0. And A, B, C. But why is the output 3? Explanation: the longest path where each two adjacent nodes have different characters is path 2, 0, 3. 2, 3. Okay, so what's happening here, I think, is that it doesn't really need to start at 0. The path can be of any path, including it can start from a child, go through the root, and end at a child. Let's look at the constraints. N is the parent length. It's also the string of Okay, for starters, before we even define the recursive definition, I think the first pass should be to create the representation of this tree in a way that we can traverse it recursively. And I honestly don't know how to do it this way, so um, I'm going to do what I've been doing previously and create this tree of type dict, and this is getting pretty easy for me because I've been doing it so much. So anyway, the child is going to be the index, and the value is going to be the parent, right? And this is for enumerate. This is how you kind of withdraw the index from the array. Let's see, parent, and since we don't care about since -1 is not a real parent, we're going to start from 1. We're going to start from 1 and populate this tree. So we have the child and the parent if tree if p sorry if p not in tree keys, tree p equals empty array, and then tree p append c. Let's make sure that we have constructed this tree correctly. I'll move myself here. For C and enumerate. Zero has 0 and 1. What? 0 has 2 and 1. I'll just say 0 and 1. 1 has, and 5 isn't near here. You know what? Probably because I sliced this array. It probably means that, yeah, I still started 0. However, in reality, my child is actually a +1. So it's 0, 1, 2, 1, 3, 4, 2, 5. Okay, sweet. The tree is built. Okay, now for the recursive definition of the longest path. The longest path for any given node is going to be the longest path of its left, or sorry, there is no left or right anymore, right? There's just the first and the second, the longest and the second longest path of any of its children. So when we're looking at a node, we have to calculate the longest and the second longest path for both of their children. And then for my current node, the longest path is going to be the longest from the longest, the second longest plus 1. So if we're still going to be doing a DFS, a deep dive into the tree, we're going to be looking at a current, we're going to have the tree, and we're going to have S. It's going to look something like this. the return value should be longest plus second longest plus 1. Longest plus second longest plus 1. Okay, so let's start with initializing the longest to 0 and second longest to 0. Now that we've initialized this, let's also have the final condition that if you're, or a leaf condition where if you're a leaf, so if current not in tree keys, I'm going to return a 1, meaning that if I no longer have any children, then the longest possible path for my parent to take from this is 1. Okay, now let's see longest and second longest. Let's keep them as this for now. Let's start going through the children and calculating the longest and the second longest path, right? So the for child in tree current, child longest is going to be self DFS child tree S. Now that the child's longest is defined, well, actually, it's here we're looking at one of the child's longest, right? So here we have to do an if. Okay, so I'm just thinking of how I'm going to populate the longest and the second longest variables, given that I have an access to every single child's longest path. So I'm thinking that if child longest is longer than longest, then second longest should be equal to the longest because we have priority. Longest. We have priority. Second longest is going to be equal to the longest, but the longest is going to be equal to child longest. However, if there's a case where the child longest is not larger than the longest, but it may be larger than the second longest. And in that case, longest equal to the longest. Child longest, let's have this return an int. Pretty sure that's why it's yelling at me. Yep. Okay, so now I've defined the longest and the second longest. For this, yeah, I've defined the second longest and the longest for each node, but now what is my ultimate longest path, right? I need some almost like a global variable. Longest path. Is there a longest path or like longest overall? Started at 0. Longest overall, actually I started at 1 because is there anything here that says that n is bigger or greater than 1? Or bigger or equal to 1. So yeah, now that we've initialized the self longest to be equal to 1, And we've also found the longest and the second longest. Let's actually set the global variable second longest to max, which is a function that takes in the maximum of the left and the right parameter that you feed it, of the longest. Right? Because here there's a possibility that there's always a possibility that longest isn't actually starting from the root. It could be starting from here. If it's starting from there, then if it's starting from there, then from this variable, then I just have to choose the longest between the, sorry, this is how it's going to be. I have to choose the longest overall, spelling longest overall to be between the longest plus second longest plus 1. Between the longest of this, let's start looking at this. The longest, the second longest, which could be any one of these, and plus 1. So it would be like 1, 2, 1, 2, 3. Yeah, perfect. And finally, we're going to be returning the longest, so that recursively our parent, it doesn't care about there being a 3 almost. I wish I had a drawing tool, but it can't be that the longest is like this and including the root. To the parent, the only thing that matters is the longest of the subtree. So that's what we're going to be returning, the longest. Okay, self DFS 0 tree s return this. All right, let's see if this thing runs. Accepted. Wrong answer. Output 2, expected 1. Expected 1, output 2. Okay, so I completely forgot about the condition that. Okay, so yeah, interesting. I got so invested in trying to figure out what the solution is for the traversal that I forgot that we actually also have a condition by which these longest and second longest paths are. Currently, we're just. Wait a second. Why? In this case, why is the longest not 1, 2, 3, 4, 5? Let's run this. Why is the longest not 5? If I am, with this implementation, I'm just finding the longest and the second longest. The longest path overall, it should be 5. It should be 1, 2, yeah, it should be 5. Uh, So I'm going to DFS. I'm saying that I'm reaching this and saying that return 1. And I'm going up to here, and since this is the longest child is going to be equal to 1, I'm saying that if the child longest is greater than the longest, which it is, let's set the second longest to 0, set the longest to child longest, which is 1, and that's it. And then set the overall to longest, second longest, which is just 2, longest 1, second longest 0, 1, since this is a 1, overall is going to be set to 2. And then return the longest, which is just going to be 1. And here, when I get to here, shouldn't I also be in consideration of this? For this guy, the longest is going to be fine too, but for this guy, shouldn't it be 3 also? I'm going to check this out. So I'm going to, the last thing that should be printed, the last time this should be printed is from the root node, second longest. So this is going to be printed a couple of times. And the last time is 1. Why is the left and the right 1? Because I'm forgetting to add a 1 here. Now it should be equal to 5. There we go. Sweet. Okay, so now that it's equal to the correct 1, even though that it's wrong, we completely forgot about I completely forgot about the condition that there has to be, the path can't just be the longest. It has to be the longest, but also non-repeating adjacent nodes. And the way to do that is we have a clear understanding of what a relationship is, right? It's just two adjacent nodes are just child and parent. So if, let's see, I'm pretty sure that if s child equals s current, then I have to continue. I have to skip out of this loop. Sweet. Okay. See this. Wrong answer. Expected. Can I get this guy? Expected 17 output. And how in the world am I supposed to debug this? Well, the good thing is that we're not cut off on 30 minutes this time, so I don't know how long I've been going for. Okay. Let's check this logic one more time. This is wrong. Just completely caught that. There we go. Okay. Sweet. Good. Actually got it under 30 minutes. Okay, let's talk through the solution with the amount of time that I have. Don't have a drawing tool, but I guess this question could be split up into a couple of different portions, and I've noticed that the previous medium questions had the same sort of structure. There is a data structure given to you that you have to reorganize into your own data structure, which we're doing here. And this is sort of like the easy portion. The next step is to figure out some sort of algorithm to use that data structure to calculate exactly what you need, and that's what we're doing here. We're doing a couple of conditions actually. We're doing that if it's a leaf node, then return 1. We've defined a longest path recursively by saying that for a given subtree, the longest path is the first and the second longest of any of the children. The sum of those two plus 1. That's what we're doing here. And we have, so essentially these two are like one conjoined piece of logic, right? And then to define yourself or child, to define a child for the parent, you also have to calculate what this longest path is, right? What is the longest path that the parent is going to care about? And that's what we're doing here, longest plus 1. This is, yeah, so structurally the question probably takes like 3 pieces of things to worry about: the data structure, the logic of finding the longest and the second longest path, and then figuring out the actual longest path. Okay, with that, I'm gonna end the video. Yep. In the comments section, please let me know if there's anything that is worth talking about, maybe, that I'm missing from these videos. Okay, thank you.